Hello everyone. Today's video is about angle theorems of polygons. We have four different theorems about polygons angles. Let's talk about each one of them by solving questions. So the first one is about sum of interior angles of a convex polygon. This is important. This point is important. This theorem, this formula belongs to a convex polygon. If your polygon is concave, it doesn't work. Okay, so we know from previous years that sum of interior angles of a triangle is 180 degree, right? That's what we learned before. What you don't know is sum of interior angles of other polygons. So by using this knowledge, by using the information about sum of interior angles of a triangle, we can deduce the sum of interior angles of any other triangle. So why don't we break any polygon into triangular parts so that we can add them up and get the sum? So let's try and see how it works. So we have a rectangle here. I can get triangles from a rectangle by dividing it into two here. So when you have a diagonal here, that diagonal divides the rectangle into two parts, two triangular parts. What we know is interior angle of a triangle, one of which is 180 degree. So we have 280 degrees. 2 times 180 degrees is equal to 360. So if we are asked to find sum of interior angles of a rectangle, it is 360 degree. So that's how we deduce the formula from the polygon, any polygon, by dividing it into triangles. So let's apply the formula and see if it verifies. According to the formula, it is n minus 2 times 180 degree. N refers number of sides. So how many number of sides do we have here in this rectangle? We have four-sided polygon. So n is 4. 4 minus 2 multiplied by 180 degree will give you sum of interior angles. 4 minus 2 is 2. 2 times 180 degree gives you 360 degree. So that proof verifies our formula, our theorem. So if you forget this formula, you can always break the polygon into triangular parts and find the sum. So let's solve a question regarding this formula. Check it out, question 3a. It's asking about sum of interior angle measures of convex 15 gun. So according to formula, we have n minus 2 times 180 degree. What is our n? N is the number of sides. How many sided polygon do we have here? 15 sided polygon. So in place of n, we write 15. 15 minus 2 multiplied by 180 degree. 15 minus 2 is 13. 13 times 180 degree is going to be 2340 degree. So this is the sum of interior angles of a convex 15 gun. All right, that's the answer of question. Check it out, question 3a. What about 3b? The 3b is about finding measure of each interior angle. So let's refer to the formula. The second formula, let's take a look at the formula. It's the measure of each interior angle of a regular polygon is n minus 2 times 180, the previous one, divided by n. So what do we know about regular polygon? Remember from the previous lesson, if a polygon is regular, all sides and all angles are equal to each other. So n minus 2 times 180 gives you sum of interior angles. And since we know the polygon is regular, all sides are equal, Suppose there are n sides. So by dividing the sum of interior angles by the number of its sides, we will get only one angle. So the angles will be all equal. We will find one angle by dividing the sum by the number of sides. So you will get each side by doing this. So the previous formula divided by the number of sides will give you each interior angle of regular polygon. Be careful, it's supposed to be regular polygon to apply that rule. You cannot do this with irregular polygons. You have to find each angle one by one in an irregular polygon. But if it is regular, you don't have to find it one by one. All you have to do is divide the sum by number of its side lengths. So how many sided polygon are we talking about here? We are talking about a regular decagon. What does decagon mean? How many sided polygon do we have here? Decagon means the sides, number of sides is 10. Right? Apply the formula. The formula is n minus 2 times 180 divided by n. So in place of n, let's write 10. 10 minus 2 times 180 degree divided by 10. 10 minus 2, 8. 8 times 180 degree divided by 10. You can simplify 10 and 180. You'll get 8 times 18, which will give you 144 degree. So this is the measure of each interior angle in a regular decagon. They're all 144 degrees. Okay. So we are done with solving questions about first two theorems. We are done with these two theorems. Let's continue with the other two. The first two was about the interior angles. The first one is sum of interior angles. The second one is each interior angle of a regular polygon. The other two are about exterior angles. So the sum of exterior angles of any polygon, it doesn't matter what polygon you have, regular, irregular, decagon, nonagon, it doesn't matter what kind of polygon you have, the sum of exterior angles of any polygon is 360. If you're asked to find each exterior angle as in the second theorem, then this time you are taking the sum and dividing it by number of its sides. Okay, similar to the second theorem. You take the sum and divide it by the number of side lengths. So let's solve, check it out, question 4. Let's start from B. B is asking about R in the polygon. We are given the exterior angles of a quadrilateral. What we know is sum of exterior angle measures is 360. So let's add them up. Let's add this sum up. You have 4R plus 7R plus 5R plus 8R. So you know that those are all exterior angles whose sum is equal to 360 degree. So add these r's up, you're gonna get 24 r. 24r equals 360 degree. Divide both sides by 24. R is going to be 15 degree. So this is what the question 4b part is asking. It's asking about the value of r. It is 15 degree. So we are done with part B. Part A, it's asking about each exterior angle of regular dodecagon. This is not about this graph, this shape, right? This shape is a quadrilateral. It's asking about R. So by adding them up, equalizing to 360, by isolating R, you get it. But in A part, it's not relevant to this figure. It's asking about each exterior angle of a regular dodecagon. What does dodecagon mean? How many sided polygon are we talking about here? Though it's talking about 9-sided polygon, right? So the second theorem about exterior angle is this. You take the sum, divide by the number of its sides, will give you the exterior angle. So let's apply the formula. The formula is, theorem says, take the sum, which is 360, divided by the number of sides, which is 9, since it is dodecagon. So simplify it. 360 divided by 9 is 40 degrees. So each exterior angle of a regular dodecagon is 40 degrees. So those were the formulas, the theorems about angles of polygons we need to know.